This is Mrs. O'Neill for AP Chemistry, Chapter 20, Section 7, Batteries and Fuel Cells. You're going to be able to describe batteries and fuel cells, which are commercially important energy sources that use these electrochemical redox reactions. So pause the video, fill in the blanks, and then play to hear my words. So what is a battery? Well, it's a portable power source, right, that has one or more of these voltaic cells. So I'm going to give you a bunch of pictures here again just to give you some visualization. But if we take a flashlight and we have two voltaic cells, each of them having a 1.5 voltage, well, the flashlight itself would have 3 volts altogether. Again, what are we doing? Adding up those volts. So a lead acid battery is also known as your car batteries. And I just wanted to show you some pictures and the reactions, again, for those of you who might be going on into some electrical work in the future. So here again is why is it a voltaic cell or a galvanic cell? Because you have your anode, which those electrons are going to flow to the cathode. And we have this H2SO4, this sulfuric acid, as our salt bridge to kind of get things moving. An alkali battery is your non-chargeable batteries, like the batteries you would have like in your remote control for your TVs. Eventually you have to replace them. And again, there's a reaction, that's just an example. And here's a nice picture that shows, again, your anode is going to have those electrons flow to the cathode, and you have that separator, kind of like that salt bridge. So these are rechargeable batteries that you probably don't see very often anymore. But again, they are in your cell phones, right? Because you constantly have to recharge that battery. But you don't see them too often, right? They're nice and small and they're inside. But again, there's a reaction that you might see in the future. Hydrogen fuel cells, those are going to be thermal energy converted into electrical energy by burning those fuels. So it's something like this. So we have your hydrogen gas and you have your oxygen gas, and again you have your H pluses moving over, so you have some hydrogen gas coming out, you got some O2 and water coming out because of those H plus, right? The H2 is turning into that H plus at the anode, reacting then with that oxygen and having some H2O come out. So again, here's our voltmeter, and again electrons are flowing from the anode to the cathode, and you have that porous membrane like your salt bridge. So I just wanted to at least show you some pictures just in case you see something like this on the AP exam. It won't be the first time, or if you see something like this in the future in chemistry courses. See you in class.